Now see a question here which is actually based on the Lenz's law and Faraday's laws of electromagnetic induction, that we know E is equal to minus d phi upon dt. And according to Lenz's law, EMF is induced in such a way that it opposes its cause of production. Now see here, there is a coil is here, that we can say a solenoid. Two ends of the solenoid is connected to resistance R and potential difference is measured across this resistance. Now when this bar magnet is allowed to fall, it is dropped from this height. As the magnet falls down, magnetic flux linked with the coil increases, but according to the induced EMF in the coil, motion of the magnet is opposed. When the motion of the magnet is opposed, so the magnet is not going to fall with an acceleration due to gravity. But see here, if you are making the bar magnet to fall over here, then it will be falling with the acceleration due to gravity. So here, as the magnet approaches towards the coil, magnetic flux linked with the coil changes, or that increases. As a result, EMF is induced. And as the magnet comes into the surface, this top layer here, top of the coil, and start going into the coil, magnetic flux start decreasing. And when the magnet is completely inside this, the coil, so magnetic flux becomes 0, the change in magnetic flux becomes 0, that means induced EMF is 0. Now, as the magnet goes to the other side, as the magnet here start coming out, magnetic flux linked with the coil decreases, and this coil induced EMF opposes this decrease in the magnetic flux and current is induced in the coil here. So now when this magnet goes out here, so magnetic flux is decreasing with the time, but it is going out here with the greater speed, and now because of that this negative peak is larger than the positive peak here. So in this case, when this magnet is completely going away from this, then magnetic flux start decreasing and ultimately it becomes 0. That will take infinite time to become 0. So now see here, when the magnet starts falling down, we can show the graph between the potential difference across resistance and time here. So first here the potential difference increases and it achieves here the maximum value, and then it start decreasing and becomes completely. It means the 0 point is here when the bar magnet is completely inside the coil. So before this, when the bar magnet is completely inside the coil, this graph is representing this side, and this we have taken the 0 point here, the reference point. And when the magnet starts going down, magnetic flux decreases and again EMF is induced. That can be shown like this. And since the relative velocity of the separation of the bar magnet is much greater than when it was approaching, that is why this peak is larger, and it goes, as it goes away from this coil, magnetic flux start decreasing and EMF will be reducing to 0, but in infinite time. So this is the graph actually between potential difference with the time. So when the magnet comes into the coil and fall through the coil and it leaves the coil at the end.